Hello and welcome to this Innovation Coffee Break. My name is Christian Schäfers and I'm the product manager of the dSPACE radar test benches. Today I want to show you how to test the separation capability of an automotive radar sensor. This is now possible in a reproducible and simple manner in a controlled lab environment with very high resolution. You'll see how the radar under test is integrated into the test bench and how over-the-air stimulation with real radar targets is done with the dSPACE Automotive Radar Test System DARTS. Imaging radars enable better environment detection for advanced driver assistance systems and autonomous driving functions. A lot of effort is currently being invested in these imaging radars, and a high resolution is the most relevant property. To speed up the development of these radars, it is necessary to check the separation capabilities in the complete field of view of the radar. In the past, angle separation tests have been an issue due to challenges in the geometry of the test setup. Our new test system consists of a radar test bench Essential 2D and a DARTS 9040 GT. A rail system enables a simple integration of two DARTS front ends that can be moved in relation to each other. With the world's most compact RF front ends, it is possible to set up two monostatic systems with outstanding simulation quality. The DARTS 9040 GT can simulate two fully independent targets with a bandwidth of 5 GHz to cover the complete automotive E-band. The two targets can be assigned to either just one DARTS front end or both front ends. This can be changed via software. The spectrum analyzer displays the spectrum of the radar at the intermediate frequency level. It is also possible to use other DARTS variants to simulate ultra-short or far distances, or a higher number of radar targets from just one DARTS front end. All these options support black box testing, because no information about the radar is required. I have mounted the radar under test into the gimbal system of the radar test bench. It is an UNDA radar that uses digital code modulation. Via the motors, the radar can be turned and tilted with high precision. This enables the simulation of targets in the complete field of view of the radar. The DARTS 9040 GT can simulate two separate targets, whose range, speed, size, and angle can be changed independently. In the UNDA graphical user interface, we can see that both targets are detected at the same range and same Doppler at different azimuth angles. By moving the front ends in the guide rail, the azimuth angles of both radar targets change until the radar is no longer able to distinguish the two targets. Additionally, we can also check the high contrast resolution of the radar, which is the capability to resolve a smaller object directly next to a large object. To test this, I will simulate one radar target with a smaller radar cross-section next to a second target with a bigger radar cross-section. As we can see, the radar is still able to distinguish the two targets with the applied azimuth offset. When I reduce the azimuth offset, the small target vanishes, and we have thereby determined the contrast separation capability of the radar for this specific value. Because the ball insert is a square, it is also possible to mount it rotated by 90 degrees to test the elevation separability. If you are interested in testing the separation capability of your radar or radar testing in general, please contact us or visit our website. Thanks for watching this video and have a nice day.
dSPACE, your partner in simulation and validation.